Thank you for introduction. Good morning, everyone. My name is Mariusz Sepczuk. I'm from Poland, from Warsaw University of Technology, and I will present the results of ongoing research of methods of access control for 5G MEC services. And the topic of this presentation is low complexity access control scheme for MEC-based services. Okay, so let's start with the plan of the presentation. Firstly, some introduction about 5G, especially 5G MEC, and an explanation why we are addressing this topic. Then I will talk about 5G security architecture and our created new access control architecture. Then I show you the steps of created access control protocol and the action performed by entities involved in this process. Then I select for a security aspect of design architecture, and I try to describe them during this presentation. And in the one of the last part of the this presentation, I try to talk about works in progress, and finally a short summary. Okay, so let's start with the introduction about 5G and MEC. So 5G is the fifth generation of wireless network, wireless technology, and it is a new global wireless standard after 1G, 2G, 3G, and 4G networks. And this 5G enables a new kind of network that is designed to connect everyone virtually, everyone with everything together, including objects, machines, devices, and so on. What is important in context of 5G, it can provide high speed, even gigabytes per second, low latency, and a greater capacity than 4G LTE. Of course, in the context of 5G, we have many industries that can use these 5G features to properly work, and some of them, of course, are more critical and require mandatory fulfillment of these strict 5G requirements. And currently, many resources are located in the cloud, and this may raise some doubts about successfully fulfilling this critical service requirement. And thus, combination of 5G and MEC can be considered. MEC generally is abbreviation of multi-access edge computing, and it brings technology resources closer to the user. So data is processed and stored at the edge of the network, and not at some distant data center. And such approach reduce latency, which is especially important in some critical services. And what is more important, MEC provides the IT environment and cloud computing capabilities to help enable the real-time enterprise. As we can see on the slide, on the left side, the left picture shows the location of MEC in 5G architecture, and this picture comes from the NSA document. And according to the NSA, MEC concept of the MEC supplements the NFV-based network function with application running on the edge of the network. And what is even more important, MEC is based on the virtualized resources which are connected with the radio access network. Of course, if we want to see even more closer what exactly is included in the MEC ecosystem, we can see it in the second picture. The second picture below the slide, as we can see whole 5G MEC ecosystem. At front of the MEC part of this ecosystem, we have the MEC orchestration, and in general, this is the entity which is responsible for orchestration and management of whole environment and whole components of MEC. Of course, MEC can consists of many MEC hosts with MEC application. This host can communicate each other, and additionally, for example, if application still needs some additional network or computational resources, MEC ecosystem is connected with 5G core networks. Okay, so we may ask why we can use MEC in 5G networks. What can MEC offer? So on the slide, the key points which have led to the development of MEC for the 5G network are selected, and of course nowadays we can observe the significant growth of IoT devices, including devices to which an IP address is assigned and connected to the internet. And of course, in such a case, we want to be able to manage of such devices. Moreover, we also can see that services such as video streaming, online gaming, or social media generate a large volume of data. So again, we want to manage such a new use case, and especially a use case which is used in 5G. And moreover, to meet the requirement for critical services, there is a need to run application services in multiple locations to enhance their reliability. And what is more important, there is a need to distribute infrastructure where services are hosted in the service provider networks, and this can simplify the management and orchestration of multi-vendor function, and especially reduce the latency in the context of new use cases, new scenarios such as autonomous cars, virtual reality, or robotic surgery. And of course, the 5G MEC network concept is constantly being developed, and new changes occur, and also in the area of cybersecurity. And one of such let's say case which we should to pay attention on it is access control, in which user want to be able to gain access to particular MEC services. And moreover, we decide to submit a project in 2020 that would refer to creating a solution controlling access to the MEC services. The project team consists of researchers from Warsaw University of Technology and National Taiwan University of Science and Technology. The Polish team focuses on the access aspect from the user end-to-end, rather end-user point of view, and Taiwan team focus on 5G radio part and potential attacks. Of course, during this presentation, I will focus only on our Polish part of the project. Okay, so the ETSI standard propose the 5G network security architecture, and this this proposal consists the elements which are characteristic for 5G network and located in the appropriate layer, control or data plane layer. And of course, due to the fact that the security requirements for MEC were not taken into account during constructing this high-level security architecture. This architecture was extended by us with new components, and especially the component which worth to mention is MEC enabler, which is we can say and treat is like a third trusted services. So the service which has role to authenticate, authorize, and account the all requested to the from the user to the MEC services. And I describe this this entity MEC enabler in a minute. In the figure, in the slide, we can notice that we have some color, and generally this color are related to the security domain. And on the next slide, I have listed all this domain. Of course, because the limited time of the presentation, I will not explain all domain, but only these which are bolded, because they are in some way associated by this main entity MEC enabler. So MEC enabler in some way try to resolve the security problem related to this domain. So first of all, we have application security domain, and this domain is the support for secure communication between application in user equipment and the application offered by service provider. And the next one is the security credential management, and this domain includes the service authentication and relevant key management between user equipment and the external data transmitting through the network. The next domain is security interoperability, also via MEC, and this domain is a support of the openness of security capability between 5G network entity and some external service provider, because in one MEC ecosystem it can be many service provider. The next one, we have network slice security, which includes security of slices in terms of access control, authorization, and isolation. And generally, the approach of slice security is very close related to the MEC services, and generally in MEC environment. And finally, we have MEC security. So this is the protection of service providers, software, virtualization platform, and hardware that supports the edge servers and MEC host. And finally, in the slide we can see the new 5G MEC access control architecture with this the main let's say component of this architecture, MEC enabler. Generally, this component acts as an external AAA server, so authentication, authorization, and accounting server for all requests before any connection with the MEC. So if the request is authorized, the MEC enabler will properly configure the process of access to MEC infrastructure, both on the application level and on the network level. And as you can see from this picture, the 5G network connects to the MEC environment using UPF core and UPF MEC, and generally the connection between these two components is established only after positive user verification in MEC enabler authorization and auto authentication process. And now I would like to focus in a few minutes about during the few minutes and talk about the modules which are included in MEC enabler. So the first module is the module which is called administration module, and this module supports all management operation and can configure other modules in the MEC enabler. The next one is slice mano, and the role of this module is to manage the slice life cycle in the MEC area. So this manager can also reserve resources for the specific slices and mark them according to service type, the network identification, and any other rule associated with the service. The next model is attribute-based control, and this model stores all policy about data associated to services, slices, available network connection, and so on. And this is a model module which can be used in the more advanced user authorization. The fourth module is service management, and this module allows checking available resources, so the service which are free to use, their utilization, and in general the number of resources dedicated to particular service when user wants to get access to the application. The fifth module is credential management, and this module creates tokens that is used for authorization to MEC resources. And of course, these tokens are during the whole usage of service are monitored, refreshed, and deleted according to the service needs. The next one is billing module. So this model is dedicated to billing and storing information about usage, MEC usage in the different context of business. The next one is UPF MEC configuration, and this model is responsible for matching and properly configuration of UPMEC and UPF core and link them to the proper MEC resources. And finally, we have a module which is responsible for authentication, authorization, and accounting of all requests to MEC services. Okay, so far I have covered MEC enabler components and their functionality, and this slide shows the end-to-end data flow in the user access control process. So firstly, the registration request is sent from user equipment to the run, and after successful registration, the request is forwarded to the UPF core element, which forwards the request that contain identity message to the MEC enabler AAA server. And this module AAA verifies if the sent data are correct, and after positive verification, authorize the data, so user contextual data, for example, user location, time, and so on. And the positive information about authorization, these data are sent to the slice mano. Slice mano, based on the collected information, check what kind of configuration for the particular service is at the moment available, and increase previously collected information with the data about this slice possibility, and send this information to the ABAC module. And ABAC module check data collected from the slice mano, and in context of some politics which are located in the local ABAC policy database. And finally, after positive verification in this ABAC module, all data with this policy information a credential management entity creates token called JMAT and send this token to the UPF MEC configuration, and in this entity is created the configuration for the network UPF MEC and UPF core components, and finally the whole request from the UPF MEC to the particular MEC server is sent. And after this 9th step, user get the end-to-end connection between his or her devices and the particular MEC service. Of course, our created architecture and in general MEC enabler provides some security feature, and I would like to discuss 4 of them. The first one is JSON MEC access token, and is responsible in general for the access to the particular service, and this token is the extension of well-known JWT token, but in this case the created JMAT token has been adapted to the specific of the MEC environments. This token JMAT includes fields information such as actor, application ID, slice ID, and of course it can be extended. And what is even more important, that this token can be signed and encrypted using a specific cryptographic algorithm, depending on the type of the service and type of the access to this service. And we perform some experiments in which we compare what algorithms are fit to the some special requirements in the MEC environment, and we of course the results of this experiments we publish in one of our paper. The second security the security feature related to our created MEC access MEC control solution is token verification after authorization. In general, token contains information that confirms that users have access to the services, and some of course data of authentication for authentication. And what is even more important, so the token is validated only when the service implementation status has been changed. It means that, for example, after usage of this service, after some time, for example, there is no need to use such such large number of slices, or in the other case, for example, it is almost the session time of the service is almost ending, so it's worth to do something with this token, for example, refresh this token. And such an approach reduces the time and resources needed for the token validation. The third security aspect is related to the two-step authentication. And the first step is related to the confirmation that user in general can use the MEC enabler server, because the MEC enabler server we treat as for example Facebook trust entity, which can be used to authorize server, and in this context we also treat our MEC enabler. And the second authentication is in this step. This is a step in which particular token, JMAT token, is generated for requested by the user service, and the user has only access to this selected service. And the fourth security aspect is involving in the access control PI-ABAC rules. So we utilize the ABAC approach to manage access control to service for users done by the Python library called PI-ABAC, and incoming request might be denied or allowed with the PI-ABAC policies evaluation, and the PI-ABAC engine evaluates the final let's say final deny or allow answer based on the Boolean decision with the rules stored locally or in memory on the servers in which this PI-ABAC is located. Okay. Our project is still ongoing, so we keep improving our architecture and our experiments. Since we have already created whole environment and we create some example of the simple MEC services, we can examine. We can perform some experiments in which we measure the network parameters in created environment, especially in the context of quality of experience of the network quality and services. And this is especially important in the context of restricted requirements of 5G rules. Moreover, we consider the optimization of selected process and solution. And what is even more important, because here we focus on the security, of course, aspect of access control. So we should create some threat analysis in the context of access control and decide to which of these threats are mitigated by our approach. And our final goal is to integrate both solutions, so a solution created by the Warsaw University of Technology and the Taiwanese approach. And as we can see, a very basic scheme for such integration is presented on the slide. And as I said previously during this presentation, the MEC enabler can be treated as a third trust part, and we can easily integrate this with the Taiwanese approach, because our colleagues from Taiwanese use the Facebook and the Google servers as authorization, the source of the authorization server. Okay, to sum up, access control is one of the security challenges in the 5G network, and as an attempt to solve the problem, a team from Warsaw University of Technology creates some example of an access control mechanism, and the conducted initial experiments show that the proposed solution meets the requirements of the 5G MEC network, especially in the area of low latency, and the solution can be easily extended thanks to its flexible design, and especially it allows to integration with other solution, especially again in the context with our Taiwanese colleagues approach. Okay, so thank you for the from the attention. From my side, it's over. Maybe if we have time, maybe some question about my presentation. Maybe you have some question.
Have you any questions? If we have no questions, thank you very much for presentation.
Thank you very much.